Yeah, hi. My name is Rod Kowicki. I'm doing this new video on superphysics. What is superphysics? Beyond Einstein. Superphysics beyond Einstein. Einstein is a 100-year-old study which he made, created a mathematical formula using light as his guide in his spaceship with Bart. I know you know the story. Uh, Bart starts off and at the speed of light, and not too long behind, Albert comes, and Albert's going just as fast in that instant as Bart. Uh, but it doesn't take into consideration the time lapse between the two launches. Even though light, now we're talking about light, like light bulb, turn on, turn off. It takes a little moments for it to become fully radiant. That's light. We're talking about light. Einstein took all this radiance and created a time travel theory, a special physics, and general theory of relativity on these perceptions. The universe is like this, he said. It doesn't matter when Bart starts off. They still are going to travel hand in hand. Well, I think it does. Like I said, it's called nano moments. It takes less than a second, to manipulate all that radiation or radiant activity. And furthermore, Edwin Hubble theory changes Einstein's view that the universe is static and not moving. The quantum physics theory, the theory I'm talking about, takes all these things into consideration. And has developed a new theory. It's not universe expansion. It's not relativity. It's not, Isaac Newton's universal gravity. It has to do a little bit about that. But it also ventures and tells you an explanation about gravity that was never viewed. And that's that universal gravity is the dominant force. But it comes from a zero vacuum. Now, how, even though it's zero, my perception of this is that it has different density elements in it, whatever it is, in space. The deeper you get, the more unsubtle it gets. It's like waves in the middle of the ocean where there's nothing but water, but yet there is waves. It's the accumulation of the shorelines, different ones at different times, that kind of like shake everything up, and all them vibrations are taken back to the center of the mass, which is the deepest. That has the more nothingness in it. It's the deepest part of, we'll call it space, vacuum. And so what I'm talking about is space expansion. Why is it expanding? Of course, Einstein's theory that it wasn't expanding, it's static, standing still. And all the energy of all the stars are manipulating each one of them and raising and lowering their electrical connections, and space doesn't like that, so space pushes on them, makes them curve. But it's not matter that tells space what to do. It's more like space tells matter, and that's it. It's the dominant force. It's everything that exists in the universe is in that space. But that space is expanding, dude. We're getting more and more space. And it's uniform, which means everything is calculated, everything is considered inside this realm, space realm. And the quantum physics theory has some explanations for this. You can look at my new book, The Cosmic Core. You can look at reverse vacuum space gravity, reverse vacuum space drive, because it's these changes that I explain in my theory that faster than light speed space travel is possible. Why is it possible? Well, we'll look at Einstein's theory, the speed of light. Everything's connected with the speed of light, so you can't go faster than the speed of light. Then we go to Hubble, 2 years later. Hey, Einstein, it's getting bigger. It's expanding, dude. Everything expanding. Look at my telescope. That became his cosmological mishap. Blunder, they called it. It's expanding. It's changing all the time. There's more space being sucked up from somewhere, let's say, is one explanation. There's a force at play in the center of the universe that's contradicting Einstein's theory. See, Einstein's theory is manipulated at the speed of light. Everything corresponds with the speed of light. But if the universe is expanding, and it's just because it's expanding more than the speed of light. Because if we accept Einstein's theory that everything's relevant to the speed of light, and something is making the galaxies change in distance, then how much that change is how much faster we're going to the speed of light than the speed of light. That's how that works. If Hubble looked in the telescope and nothing was happening, Einstein's still right. Doesn't mean he's right, but that's what he says. And what I told you about light is not the universe. Space is the dominant force. It makes everything what it is. The space expansion, was formed from the Big Bang. For a long time, everything was subtle. It didn't move. Or we didn't think it moved. Or the entity of the expansion was so weak, so small, so young, that it took a lot of years, let's say 1 billion, till the universe started expanding. And that expansion is what causes momentum and motion amongst the celestial stars, planets, stars, galaxies, everything. Everything inside a galaxy is uniform relative because they're inside that galaxy. They don't expand. Matter doesn't expand. Space expands. And it's space. That's why space is the dominant force. Now, in my theory, the Big Bang is not only the end of one universe, but the beginning of the next. If we look at it this way, the Big Bang happened because the first universe collapsed. Everything something happened. Well, actually, it collapsed over billions and billions, 4 to 5, maybe 50 billion years. Now the universe is only 14, but let's take it into perspective that relativity doesn't have all the answers. So the universe collapsed for whatever reason. The energy content, the loss of life, energy was all used up, and it collapsed. It collapsed. But when it collapsed, it regenerated. That same explosion, what you want, or eruption. See, the difference between explosion and eruption is eruption. It doesn't go anyplace. It's inside space. It's caught inside this dilemma of space, of which space is the dominant force and tells matter what it can actually do. So matter, even though there was an, let's say, explosion, which we're going to call an eruption, had no place to go because it was in the middle of infinite space, let's say. In other words, matter has to be someplace, and it's in space, it's in the vacuum. So the idea that we evolved from nothing is not so correct. Now, when it collapsed, everything regenerated, reformed, took all the energy and boosted it back up. An explosion occurred. Explosion couldn't, like you have an explosion in a house, pieces all over. These pieces had no place to go. And they all came from a center of mass of that explosion. So they exploded, but as they regenerated their energy and everything, they shrunk back to what they were. And this shrinking back created something that in the center of the universe, because of uniformity, started to expand. Even though it was there, it could be what do they call it? The density was so great that it's like an inflating balloon that's an egg, and it's actually what do they call it? Normalizing and getting bigger and bigger. Eggs don't do that though. But we can call this entity Hubble's sphere, some sort of manipulation of some sort of deity, whether you call it an element. Is space an element? I think it is. Derek's C in the comparison. But something is expanding the universe, and that expansion comes from the center of the universe. And it's making as it gets bigger, it's pushing on the galaxies where everything is in all these galaxies, that because of gravity wells, in other words, the flexibility of space, all the galaxies are accumulated all around this deity, whatever it is, this sphere, this void, this bubble, whatever you want to call it.